This is the pre-lab lecture for the KSP of nickel hydroxide lab that's done in general chemistry. In this lab, you're going to investigate a precipitation reaction. Specifically, you're going to investigate when nickel 2 plus reacts with hydroxide to form solid nickel 2 hydroxide. Now, what we in the end want to determine in this lab is the KSP, or solubility product, for that reaction. And that K value is equal to the concentration of nickel 2 plus ions times the concentration of hydroxide ions squared in a saturated solution of nickel hydroxide. Now, in order to determine this, you need to measure those two quantities. Well, the nickel 2 plus is green in color in aqueous solution, so we're going to determine the concentration of nickel 2 plus spectroscopically using the colorimeter. OH minus can be determined by measuring the pH of the solution. And so what you're going to do is measure the concentration of nickel 2 plus and the concentration of hydroxide at several times for saturated solutions of nickel hydroxide. Now, in the end, what we want is this KSP value, and in principle, you can determine that if you put some nickel 2 plus and hydroxide together and you form a precipitate and you measure the concentration of the nickel 2 plus and the hydroxide to determine the KSP value. However, there are some subtleties, and in particular, what happens is the solubility of things, in this case nickel hydroxide, change with changing concentrations of ions, which include spectator ions. And this is discussed in detail in analytical chemistry. However, for our case, what we need to do is measure and determine, we need to measure the concentrations of the nickel 2 plus and hydroxide several times and calculate KSP values for all of those different concentrations. And so what we can do is we can determine and calculate a KSP value for several different concentrations of nickel 2 plus in an aqueous solution with the precipitate formed. What we would expect is these form a linear trend that we can fit a regression equation to, or line. And what we want to do in the end is find the KSP value for what we call infinite dilution, when the concentration of the ions becomes very, very small. And in this case, in particular, we want to project that back to 0. And so that, where that y-intercept is on that line, is going to be the final answer that you come up with. And so we're going to determine this at several points. And again, I've discussed how you're going to calculate the concentration of nickel 2 plus and how you're going to determine the concentration of hydroxide. The lab is broken into two parts. The first part is to construct a calibration curve for nickel 2 plus. Nickel 2 plus, as mentioned, is kind of a light green color, and so it will absorb 635 nanometer light. There are 5 solutions already prepared, and so you're going to create a calibration curve so you have known concentration of nickel 2 plus, and you're going to measure the absorption of those. And so you're going to have 5 different solutions. You can fit a line to that, and so you can determine and have a mapping of absorption to concentration of nickel 2 plus, similar to what we do in other labs where we use colorimetry. That's the first part, to measure and determine that calibration curve. The second part, you're going to be doing a precipitation titration. And what needs to be done before you start that is you're going to be using a pH meter, and you need to measure the offset of that. Ideally, we'd expect the pH meter to measure 7 for a pH 7 buffer. However, your reading may be off slightly from that, and so you need to measure a solution that's known to be pH 7, and maybe you measure the solution to be 7.10 for the pH. And so you know that all of your pH readings are going to be high by 0.1 units, and so then you can correct for that when you do the calculations. So ensure that you measure what that offset pH is going to be. The next step is to measure the nickel absorption and pH for several saturated solutions of the nickel hydroxide. How that's done is using a setup that's shown in the photograph on the right-hand side. You're going to have a beaker placed on a stir plate, and in that beaker you're going to have nickel chloride dissolved. There's going to be a stir bar, so we're going to be stirring this solution to make sure that it's agitated. And what you need to do is you need to determine, and reading in your lab manual, what mass of nickel chloride hydrate you're going to need to dissolve in the 50 milliliters of water. So make sure you come to lab knowing what that mass is. So you're going to dissolve that, and initially that's in water, okay, pH roughly 7, and so there will be no precipitate formed immediately. That's going to be a nice green solution once you dissolve the nickel into it. Also in this beaker, what you see are a pH meter, that is the blue thing in this photograph, and there's a burette that has sodium hydroxide in it. You're going to drop sodium hydroxide into the solution until you see a precipitate form, and the precipitate will be a white precipitate. And immediately when you see a precipitate form, you will stop. So you're going to add it drop by drop until a precipitate forms. When you see a precipitate, you will stop adding sodium hydroxide. At that point, you will measure the pH, and you will remove, using a pressure pipette, a transfer pipette, some small sample from the beaker and put them into a small test tube, which we will centrifuge. The key feature here, several things that you need to be aware of, is make sure that the stir bar, which you need to agitate the solution, is not going to hit the bottom of the pH meter. The bottom of the pH meter is fragile, and you need to be careful that you don't damage it. It gets a bit congested, but it's easily doable in order to get all of the stuff in the beaker. In terms of the burette, make sure that it's dripping into the beaker, and using a 3-fingered clamp with your pH meter, and that gets into the solution. So the setup here is a fun one to do. Now, once you create the precipitate, you can easily measure the pH using your vernier unit. But the solution, once you pipette it out into test tubes, it might look like this. It's a bit cloudy. And that's a problem because absorption spectroscopy requires a clear solution. And here you have a cloudy solution because there's a precipitate. So what we're going to do is, in those test tubes, which are special test tubes for the centrifuge, you're going to put them into a centrifuge. You're going to turn that on, and you're going to let it spin for roughly 30 seconds before shutting it off. And after you take those test tubes out, what you can see is that the solid has settled to the bottom, and you have a clear liquid on top. And you can use a new transfer pipette, a separate transfer pipette, to take some of the liquid out here and put it into your cuvette where you can measure the absorption. Key things here is that you need to ensure that you use 2 separate pipettes, one that's kind of quote-unquote dirty for the precipitate water, and another one that's clean for after you're done centrifuging. The other thing is, when you have the centrifuge, it needs to be balanced. Depending on the model of centrifuge that you have, there may be 4 or 6 holes, generally 4 holes. You need to make sure that these 2 test tubes are on opposite sides of the centrifuge so that it's balanced when it's spinning. You don't need to have all 4 of them filled. However, if there are 2 groups that are ready to use the centrifuge at the same time, you're welcome to do that, as long as you can identify which test tubes are yours and which are the other groups. Now, a couple of more other details with this. You need to be careful when you're adding that hydroxide. You don't want to overshoot initially, because then you're going to have problems later on. You want to add just enough that you see a permanent cloudiness, which is an indicative that the precipitate's being formed. After taking out and centrifuging your solutions, you're going to measure the absorption of those and record the absorption and the pH for each of those trials. You then add a little bit more sodium hydroxide such that the pH will change by about 0.1 units. So a small change in hydroxide concentration, so just a few drops. You then will repeat the procedure, recording the pH, taking out a sample, centrifuging it, and measuring the absorption. You want to get at least 4 pH and absorption measurements when you're going, and 5 or 6 is also okay, but you want at least 4. Some words on safety. Nickel 2+ is a mild irritant. It's not super hazardous in the lab. However, it's an environmental hazard, so it cannot go down the drain. Also, you're adding base, and so you need to be aware that sodium hydroxide is hazardous, and you don't want to spill that on yourself or anywhere. And if you do, you need to notify the instructor or the laboratory assistant so that we can get it cleaned up and rinsed off quickly. And because you have basic solutions, those need to be collected as well. So everything in this lab, all waste will be collected. Okay, so make sure that nothing goes down the drain. Be careful with the centrifuges, that when they're spinning that you stay away from them. So make sure that you are careful when using those. And that's all of the safety considerations that we're going to talk about for this lab, and all of the detail on the experimental procedure.